Hello, everybody. Are we live? Welcome, everybody. Are we here? Hello, hello. Welcome. How are you doing? How are you today? My browser will not pop up, which is an interesting factoid. Eternal Wild Fox says, good evening. Good evening, how are you? OBS had always on top on for some reason. It looks like I am live for some reason. I can hear myself, so that's good. We look to be in good stance. Eternal Wild Fox says, doing well. What about you? I'm not doing too bad. I'm not doing too bad. Had a bit of a late morning, but it's fine. Happens all the time. We are going to be working more on our glorious compiler. So I should probably make the announcement that we are live. Thank you for asking, Eternal Wild Fox, though. I very much appreciate your inquiry. You're doing not too bad this morning. Not too bad. More compiler. Yeah. We're just gonna do compiler. Part 15. You know what that means? That means that at the end of today's stream, hey, my phone's not on silent. It's a good thing. I can fix that now. Part 15 means at the end of this stream, we're gonna have 45 hours, pretty much, of work on this compiler. CyberPatty says, hey-oh, how's it going, CyberPatty? It's great to see you. Alrighty. Alrighty. Thank you for tuning in, CyberPatty, Eternal Wild Fox. I'm glad we are here. So let's just try and get main open and get a compilation happening. I guess I should do that from here. Gonna run CMake. Whoops. Yep. I'll have screwed it up. Nope, not that. CyberPatty says, good, thanks. Hope you're doing good as well. Thank you. Not doing too bad this morning. Okay. So we're going to use CMake and build our debug directory, our build tree, and then run the executable it generates, and then pass the executable some file path, because we need a file to compile for our compiler. I think we have some basic examples here. So I thought about it a lot, and this syntax just felt way too heavy. I mean, this one's not bad, but it just felt like too much. Grammar 2 Parser Boy says, hello. Eternal Wild Fox says, I think I have another look into iterative tree traversal because I can. Lamau. Yeah, tree traversal it's a pretty tough programming problem. But that's a lot of what compilers are, right? It's just trees and just traversing them. How are you doing, Grammar to Parser Boy? Thanks for tuning in. I see you've been active in the Discord. Okay, that's right. So this syntax seems a little too heavy. So I want to allow for something that's a little better, right? We can have, for example, this integer identity function, which just returns the integer you pass it. right? This is how it could be defined. Because in C, you need the return type, the symbol, the function name, the parameter list, and the expression list, the body. So I wanted to kind of make it a little simpler to declare functions. So we're going to have this syntax allowed. And it is going to be tricky to discern sometimes between what may be something like this. We may end up with like foo none that, or we could have foo none and then 2 plus 2, right? So the issue is that these two statements will kind of look a lot like this one, which is why the braces have been introduced in the other one that we currently use, because it's easy to detect when there's a brace. A square bracket, I should say, not a brace. But yeah, so using the square bracket in this shorthand allows us to parse it much easier and not have confusion. And it also allows us to write lambdas the same way that we write function definitions, which is also a good thing. But it seems like just to have an integer identity function, having it be this verbose with so much typing, like, it'd be like, you just end up using a lot more symbols. Basically one more and then this set extra. It's not too bad, but it could be extra if you have if you're writing a lot of functions, right? And I think that's part of why C is so popular, because it's so simple. So I don't know. We're still deciding on syntax this late into the development, which is always good, right? Everybody loves a little bit of bike shedding now and then. Okay, so then we want to pass it the example file. Sure, save it. And hey, look, it works. This is all commented out, so let's actually see what it should be. There should be a function call foo last. Function call foo with two integers, 20 and 34. What if we call... I don't think this will be detected. If we call a function that hasn't been defined. Compilation exited abnormally. So we definitely have a case to handle here for an undefined function that we're not handling. What about different amount of arguments? Did we do that yet? We did. Function, foo, invalid arguments, not enough arguments passed function. Perfect. We even tell you not enough. So I assume we have not enough and too many. I assume we have type checking. I see. Argument amount is checked before the type of the arguments. That makes sense. Alrighty. Well, I think we have a good start ahead of us. We also have math, right? Oh yeah, a lot to do. So let's try and compile math. And in math, we actually have a nested function definition, which is a little complicated. And then we have some binary operators, which do precedence parsing. So we have precedence parsing, as you can see, 2 times 3 over 2 plus 1. You get 2 times 3, 6 over 2, and then the result of that is the left-hand side of the plus. So it goes in the proper order, putting the ones we encounter first at the bottom if the precedence is higher. Or if the next precedence is lower, I should say. Very cool. And we have a function definition, which is foo, with an x integer parameter returning an integer. That all looks correct. Within it, it has a variable declaration to the symbol bar, yes, which is a function of the symbol y integer. It returns an integer, and all it is a variable access of y. Hey, look, that's correct. So if it's a variable access of x, I'm curious what happens. It's still allowed, so we don't check really for invalid variable accesses. So this is something we could type check. Let's just add this to the to-do. Right? Type check variable accesses. Accesses? Axi? Does anybody know how to say that? So type checking those. Type check and validate, we'll just say variable access. In any case, oh, I guess that might be fine because there's an x integer here. That's just me not paying attention. Let's put z in. See, z is still allowed, so it stands. In any case, we have a to-do being spit out here. Isn't it just access? Maybe. Multiple accesses. It wouldn't be multiple access. That's not how American English works, at least. I don't know. There's got to be some plural form of access. But we have to do local variable declaration, so let's find that little ditty. Alrighty. So local variable declaration probably comes when we are trying to define bar, codegen bar, in the function foo. So this global function foo, which is this function here, contains a variable declaration, and we don't know how to codegen that. CyberPatty links to word hippo. What is the plural of access? The noun access can be countable or uncountable. The plural form will also be access. However, in more specific contexts, the plural form can also be accesses, e.g. in reference to various types of accesses or a collection of accesses. So accesses is correct, according to the wordhippo.com, which I don't know if they have the authority on English, but it's definitely a source. CyberPatty says, yeah, you were right. Nope. Lamau. Alrighty, so local variable declaration means that, oh, we literally have it here. We need to allocate space on the stack, and then keep track of our base pointer offset. So if we look at how we generate a function, you can see that the first thing we do is save RBP on the stack, which increments the stack pointer, right? Pushing. But then we move the stack pointer into the base pointer. So we save it on the stack, and then the base pointer is effectively overwritten. The base pointer now points to the base of this function, and you can see that currently we just sub and add 32, which I don't think we actually need, to be honest, but we can create stack space anyway. It really doesn't matter. CyberPatty says just the first source. Whatever comes up first. But you can see that with this is an empty function declaration because we hit the to-do. So the idea would be that we keep track, since we know the stack pointer was set here, and then the function enters with just 32 on the 32 bytes added to the stack, right? So we effectively have our base pointer. Yeah, we have our base pointer 32 bytes above our stack pointer or something like that. Grammar to parser voice says, why no indentation after a label? Because this is generated by the compiler. I didn't worry about like putting tabs in because it really doesn't matter. It's just line by line is really all assembly is. Basically just to make it easier so I don't have to keep track of each line having 4 spaces at the beginning or not, right? But you're right, I could just indent the whole thing. Emacs has auto indentation of assembler. It doesn't matter. But yeah, so the grammar to parser boy says, yeah, but could be more readable. Maybe. It's I guess I've worked with assembly too much, so you kind of get into the line by line mindset. Doesn't really affect how much each one is indented, right? But it is easier to see the overall structure, I would agree. Alrighty, but yeah, so you can see that we have 32 bytes on the stack, just to make room in case we make like calls to variable functions. We need shadow stack space. It's not important. You don't have to worry about why we need some space. It's probably not needed in every function, and we could definitely reduce it, and it probably will make things inefficient, so we'll fix it eventually. But for now, everything's offset by 32. So if we wanted to push a value here, or just subtract something from the stack pointer, like we do here, this allows us to create space on the stack. So then the offset from the RBP, like the difference between the stack pointer and the base pointer, can grow. So they get further apart, right? And then you're able to insert more variables in there. And that's how local variable declarations work. You just have to keep track of your RBP offset. So I think each codegen context is going to contain, or we could store it in the locals environment, because we need kind of like an offset per context, so that when we create a new local, we know where to place it. So the idea, we could either just have, I guess we want this an integer, locals running offset, or we'll just say offset. Do we have like a codegen context create? Do we do that? CG underscore context equals, we do. Can you take me to this? It's one of the finds. There it is. Whoops. Yep. I always screw that up. There we go. Okay. And the context we return should have an offset of 0. Well, it should have 32. Right? We'll go with the 0, and then in x86-64 program, we will add 32. Yeah, that's fine. That's fine. So, oh boy, we're gonna have to look at stack addressing. So I think I want to use the Compiler Explorer, which if you haven't seen it, is this very cool website. Yes, they do things. It's a very cool website. Ooh, Eternal Wildfox says, "Oh boy, stack addresses." That's right. That's what we're working on now. So you can write some code in any of these languages, and then using compilers, you can see what the assembly they generate is, and you can pass compiler options to the compiler. Cool. So Jopi Dawala asks, are you directly translating to assembly? Yes. This is what compilers do, as you can see, for all these languages. So that's what we will be doing for our language. at least for one of our output formats. We're also going to output to other formats. But yeah, we're writing assembly ourselves. It's fairly doable. So we have some stack offset. Let's just make int main so this is easier. Void. This is, can I write in C instead? Thank you. Oh, good. You redo everything. Okay, I'm used to emacs. My B. Jopi the Wallace says, but not directly, right? There's some syntax tree and all. Oh yeah. Yeah, there's much stuff going on in between the source code of our example. Because this is the source code, which then gets passed to our parser from main.c if you can see. So our first argument to the program, to our compiler on the command line, gets turned into a file that we try and load, and we parse a program from there. So parsing a program then does a bunch of calls to like parse expression in a row forever until we run out of file to read, right? And parse expression creates expressions, which are nodes in our AST, our abstract syntax tree. And parse expression uses lex. So we have a streaming lexer that the parser lexes from. There's many stages. And then in main.c, we then go on to type check the program, which is, we just started. It's not really that robust yet at all, but we're working on it. And then we go on to codegen the program. So our type checked AST becomes a codegen program. Hopefully that helps you out a little bit. So let's say we create a long integer. We name it something like A, and we just want to allocate space for it. You can see that GCC is very much an optimizing compiler, and they effectively don't do stuff unless you really make them. Yeah, here we go. So this should be fine. So you can see that this is also Intel syntax assembly. Can we change this? Thank you. So you can see that main pushes the stack pointer as one does the base pointer, excuse me, not the stack pointer. Then they move the stack pointer into the base pointer. It's a little, yeah. And then we move this stack address into racks because this is our return value. And what this stack address says is that go to the base pointer, -8 from it, and that's how you'll get what we're moving into racks. Read the value from this address. So the idea would be figure out how our base pointer here, does -8 go upwards or downwards? Does anybody know? I think the stack grows downwards. So -8 would refer to lower on the stack. And oh, okay, this is very interesting. So remember in C, if you just declare a variable, it becomes uninitialized memory. And here is why. The assembly that is generated, you can see references -8 from the base pointer, but that was never actually handled, right? There's nothing that says, oh, there's space here on the stack, because we didn't use it. So the stack, whatever was there before, was just used. But now, you can see that we are able to move 0 into the stack, and then we can move that into racks, which means it is initialized. So that's how C has uninitialized variables. It just uses whatever's on the stack before, because that memory may not be 0, it may be 3 million, 3 billion, right? It doesn't matter. include C++. With, I don't know what this is. Also, these are not my sponsors. These are sponsors to the Compiler Explorer, found at godbolt.com. Which doesn't show up for some reason. Very cool. In any case, we can see that we basically have to address the stack with an offset. So that's what we're going to be keeping track of here. And remember when I said we don't always need the subtract and add on the stack? GCC is very much an optimizing compiler, even with -0. Is the access to uninitialized variables undefined behavior? CyberPatty says, oh, but the compiler will greet with an error for that. No, C completely allows uninitialized values. Like, this will work. There's nothing wrong with this. But the value that you return isn't set by the program, it's set by the OS when it allocates you the stack. If it sets it all to 0, well, then it'll be 0. But if it doesn't set the memory all to 0, then you'll just get whatever was in that memory before, which can be literally anything. So, yeah. Joe P. DeWallace says garbage value is assigned. That's not true. There's no assignment here in the program. There's no assignment to that variable. CyberPatty says right, so some garbage possibly. CyberPatty has it right. CyberPatty has it right. And OSs want to be as efficient as possible, so they tell programs, yeah, the stack might be uninitialized. There may just be anything there. Don't rely on it being 0. So OSs just don't deal with the stack part for performance reasons, because doing mem sets every time you make a new program takes a long time. Joe P. DeWallace said, I missed a little bit earlier, downward stack because operation right. I'm not sure what that means. Because minus operation right, there's a dash in there. I don't know if that's related. Okay, so... Okay, yeah, you're saying the minus means that it's downwards. Not necessarily in stack land. I always get confused. Because the stack grows downwards. So I always get confused, like, does that mean when you add to it, it goes down? That's the bottom of the stack? Or does that... But I think it grows to the left so that the stack pointer points to something on the stack, rather than the stack pointer pointing to the next thing on the stack. So yeah, you're probably right. This is downwards. Which is confusing, because there's no actual stack space allocated for it, for the function, right? It's kind of just relying on the what calls main. But GCC is built so that it knows what calls main and can do things like that. Okay, so local variable declaration, allocate space on the stack. So the reason we have to do this step is because RSP should point to, well, I guess it doesn't have to if we keep, here's the thing. You never have to keep track of the actual stack pointer if you keep track of the base pointer offset, right? Do you ever have to subtract actually on the base pointer? I think you can just use the memory, and I think that's what GCC is doing. They're like, we don't need the stack pointer. We never actually use it. We do when we push and pop things. So if you're going to push and pop, you're going to need the stack pointer. But if you don't push and pop anything and you're doing direct addressing with offsets from the base pointer, we're never really going to need that stack pointer, right? So this allocate space on the stack isn't truly needed unless you push or pop things. We're still going to do it, though. So we're going to have to get the size in bytes of the type of the variable so that we know how much stack space to subtract from the stack pointer. Keep track of RBP offset. Yes, so then we're going to have to figure out where this stack space was allocated and wherever the stack pointer now is after subtracting. Okay, so we're gonna just add that. Subtract type size and bytes from stack pointer, just so we really lay it all out for ourselves. Okay, then keeping track of the base pointer offset. This is going to have to be kept in Codegen context so that locals can be added and subtracted properly in nested scopes. I think that makes sense. So we keep track of the base pointer offset kept in the Codegen context. And we know the base pointer offset because every time we do one of these things, we update it, right? So then nothing else will change, push, or pop from the stack other than the things that we actually code gen, so we should always be able to keep track of our base pointer offset. That sounds reasonable. Let's start writing some code. So we're gonna start with a sub, it seems like. So we're gonna do right into the code. Yep, not like that, like that. And this is going to be a sub from, I think, we subtract left to right in BCC. Yeah, so we subtract 32 from RSP. So it's kind of backwards. So RSP will contain the destination. Okay, so we need to subtract something from RSP, and it's going to be some number. So what number will we be subtracting? It's the size of the type. So how can we do this? Do we have... We can't make variables within switch cases in C very well, so we're gonna do it this way and make a long up here, which is gonna say stack offset. Sure, why not? We'll just set it equal to 0, because why not for now. Alrighty, so we're gonna say stack offset equals, I guess we may not need this if we can just access it pretty easy like that, huh? We don't need our whole own thing. I was being a little, got a little ahead of myself there. Yes, do that, please. And this is definitely a long. What's your issue? Data argument not used by format string. That's fair. So this will subtract the amount of space. This will do this thing. Not at all. That's the wrong place. So look at me getting ahead of myself once again. That's here. Just gonna smack that down there so I don't forget again. So we need to, yes, we're doing that. We need to allocate space on the stack. So get the size and byte. This is why I write the comments, by the way. Get the size and bytes of the type of the variable. So what type is this variable? We're gonna have to parse get type. But we're gonna need, oh Christ. This is gonna be rough because we're gonna need we're gonna need the variable type here, which is stored in the variables environment. Oh boy. So we're gonna have to do a while context type of thing. Okie dokie. So while context equals context parent, but there's a condition we would like to break underneath, and it's the case that we are able to get from the context variables environment the current expression's child. Since it's a variable declaration, that should be the symbol. Does variable declaration contain the type? And I'm doing one level too much here. Not today, huh? Okay, not today, huh? I'm gonna do one of these. Put 3 so I know which ones to get rid of. Now we can look at our sweet little thing here. So we do not have the type in the variable declaration, but the first child is the symbol. So we can use this symbol in the variable's environment to get the type, and then we can, from the type, get the variable type symbol. Okay, yep, okay. We're gonna need temp node or something here. And we're looking for the expression child into temp node, I would guess, but that may not work. I don't know if that's gonna work well. You know what I mean? Writing into the same node that we are searching from may cause problems in parse get type, but we're gonna try. And these return an error. So return that error if it occurs. And we would like to say that temp node has a child, which is an integer, and it's the size of the type. What's your issue now? Expected environment, but our got environment pointer. So we just have to dereference this environment. There we go. Okay. We don't break like before. Type not found null. Okay, so I screwed something up because we definitely have function and integer types, which is what we should have, right? So let's think about this. CyberPatty asks, what autocompletion package are you using? And also, Adderson28 followed. Thank you so much for the follow, Adderson. I very much appreciate it. Be sure to check out that Discord down below. We would love to have you there. We have a lot of fun. We're all very active here. And learn together. Okay, auto-completion package. I'm using company, if I could spell it. Company mode. It's complete anything. It's an in-buffer completion framework. There you go. It's really good, and I like it. It's fast, and it doesn't get in the way unless you're like in the scratch buffer or a shell. But you can just turn them off in those. I'm just lazy and haven't edited my config enough. Yeah. CyberPatty says it seems good. Yeah, that's awesome. And I also use Emacs's built-in deabreathe. So if we look at deabreathe, expand, you can see that you just press Alt/ and it expands the previous word dynamically, which is it's kind of weird. But for example, if I type like ER and then just keep pressing Alt/, these are all the things it cycles through, which is pretty handy. It's literally everything, right? And then it cycles back around. So you can see Alt/ combined with company, where I have it integrated with Egglet, my language server, so that I get the right thing. CyberPatty says Alt/ was the first thing I found. Funny story, I actually used Emacs for like 6 months without ever knowing about Alt/. Did not know it existed. So I used company only. And I was like, oh, that helps a lot, because you can type properly, right? Or prospect. I haven't typed prospect, but if that makes sense. CyberPatty says, I tried Emacs for the first time a few weeks back. That's awesome. That's very cool. We always love to see new users. So this should be fine. But the type is not found null. So that definitely has something to do with this, right? So let's think about this. In which I'm looking in the variables environment of here. So which variable am I looking for? Let's go ahead and print ourselves that information. Local variable blah. And this will be expression, children, value symbol. Local variable bar. So it's looking for bar. How was your experience with Emacs, CyberPatty? Did you enjoy it? Or was it, my first time with Emacs was a little frustrating. I was like, there's way too many buttons, and it's way too complicated. This is not okay. But then I kept crawling back. I was like a slimy addict. I was like, I hate it, but also, give me some more. So we're looking for bar. Could we then print, what did we do? So local variable bar, but then environment print context variables, we get nothing. So maybe we're not entering the proper context upon, we're trying to do bar. So where's this bar variable declaration? It's within a function. What is happening? Stop, Emacs. CyberPatty says Maggot is godlike. That is all I can say for now. It's one of the best Git porcelains. I would agree. Sorry, excuse me. Ooh. Hey, Adderson, thank you so much for joining the Discord. It's great to see new users. We really appreciate that, and we're excited to have you in the community. I don't even know what button I just hit, but I am going to wave. Hello. That's a good one. Okay, so type not found null. We're not finding this because we're probably not entering the proper environment, but then, yeah. So we're probably entering Codegen context properly, but not in the sense that we need to. So you can see that Codegen context, we create a new one. And what we would like to do is also enter the next context, right? So ideally, here's the thing. When we codegen a function, we should pass it the context it's within. So then we should have to, or should we just pass it the proper contexts? You know what I mean? First time chat from a viewer. Adderson28 says, this was my first experience with Emacs. Little frustrating and sad. Yep, lol. Definitely lol. CyberPatty says, I'm not using it every day, but if I'm not in a hurry, I might pop Emacs open for a session or two. Just need more time and configuration. And time. And there's never enough. You are correct. So funny. So if we check out the type checker, I don't think we're doing the context thing properly either. We're going to have to look at how we create them to see how we can properly traverse them. So for lambda, we say parse context create. So what this will do is add the child to the parent. So effectively, we just need to keep track of which child we're on and then use the next one. Is that correct? CyberPatty says, I did not like C chords when I tried them for the first time, but it grows on me. Vim just is not as convenient anymore after changing keyboard layout out of QWERTY. Nice. Do you use Dvorak? That's an intense, dedicated decision, because the entire world is QWERTY. Cyberpatty says colmac. I've never heard of colmac. That's a keyboard layout? That's incredible. I'm uncultured, I'm sure. So the problem is, we would like our context to equal context children, but not one of the child, right? Not the first child. Well, maybe the first child, I don't know. But if we've already parsed, then we would want a different child, right? We wouldn't want. So let's try and get past the parsing context that we properly need when codegenning a function. So global functions will always have the global context, so we don't have to worry about that. We just have to worry about it in codegen expression. Wherever it is, its recursive old self. So here, if it's a global function, we don't need to actually codegen anything because we do that separately. Let's look into colmac a little bit. I'm kind of curious. It's an alternative to Dvorak. Okay, amazing. Ooh boy. It's optimized for using the home row as much as possible and also to use both hands or at least different fingers between each letter. Okay. This is that's intense. So yeah. This is odd over here. The right pinky would get some odd. Yeah, that'd be hard to adjust to. This is cool though. It's definitely usable. I kind of want it on like a split columnar keyboard, right? That would be sweet. It's a good idea. It's a good idea. Cyberpatty says, I never used my pinky with letters before. Lol. I mean, I just hit P. P is the only pinky letter, which is pretty funny. Cyberpatty says, I have one laying ready to be soldered. Lamau, that's awesome. You're building your own keyboards. That's so sweet. Is it mechanical? What switches? What layout? Did you do like Lily 58? Do you get corn? What do you got? You got a corn, nice. The corns are very sweet. I'm scared of going without the number row though. That's why I want a Lily 58, truthfully. Because the Lily 58 still has numbers. Because I use numbers while coding. I'm scared to have to use another layer just to remember numbers. But I know it's all doable. Yes, that's probably important. So we have a function, we need to enter it. So we kind of need codegen expression to know what the next scope should be, right? It's almost like we need to do this at every level. Have the next context kind of built in, so then we can update this pointer as we use it. Or we could have the parsing context. Because there's no way we can know this context, which one we've done. We're in the middle of a single expression, so we need to pass some sort of state so that we can tell which context we're actually on currently. Which is sad, but it's fine. Next child context. Sure. Yes, tell me your ways. Why are those blue? Oh, I didn't add commas. They think they're types. I was like, why are they blue? So let's do something like that. Cyberpatty says, my friend has an odd hobby. My friend has an odd hobby of gathering switches, so he should have something for me. I'm going to try what I want after his wedding next week and the honeymoon. But yeah, probably not cherry. Nice. I've been looking at like I want to get TTC blue-white switches is what they're called. But they're supposed to be like very quiet. And I want to switch from my current blue switches to something that is absolutely quiet. Cyberpatty says bluish whites. Nice. Yeah, that's what I want next. When the budget allows. Get this loud old keyboard out of here. This keyboard is like 8 years old at this point as well. It's terrible. Cherry MX Blues. Cyberpatty says some box ones would be nice. It definitely helps with the dust, right? Are you talking about the kale boxes that have like the different stem? Thought I did that, but whatever. Cyberpatty says yee. Definitely, that would be very nice. Not have to worry about keeping the keyboard clean so much. It definitely is memory leaked. So our issue is that we need this state. How do we get this state? We're going to need the next child context. So we still have to look for cogen expression calls. And maybe it should even be like a pointer like this, right? Is this within function? Okay, Christ. This is probably the worst way to do this, by the way. Don't at me, please. So when we are cogenning a program, we would like to say the next child context is what? Well, first it would just equal the children. So do that. And this is going to equal, then we can just use next child and continue on our way. Cyberpatty says, I already got the blank F10 keycaps in my old board. Cyberpatty, blank keys really helped in learning the new layout. That's insanity. Not only did you switch layouts, but you did it with blank keycaps? You're insane. Are you kidding? That's incredible. That's pretty impressive. Just saying. Just try Colmac Academy. I'm not that I don't have the keyboard yet. Speedrun, kick W. I see, but these aren't going to be right. For these global functions, we don't want to do that. Oh, this sucks so much. I'm not exactly sure how to proceed. And it's on something so simple as how do we traverse the tree that we create. What's your issue? So you don't get called, right? But the issue, so if we pass it next child context, it's going to update it. So what if we just pass null? Then we would just not do it. Kind of seems sus. Cyberpatty says it got the keys on the screen and alters the key layout. We're checking it out. Oh, Christ. How does... What? Oh, boy. Nope. Nope. Okay. Oh, boy. Yep, this is rough. This may be the worst uh words per minute I've ever scored. Uh this is so hard. Eternal Wild Fox says just walk the tree or climb if that works better, Lenzer. BRB, headphone battery death. Be right back. Lamau. Cyber Patty says that's so funny. I got like 9 words per minute the first time. Yeah, I'm gonna get less. I'm not so great at this thing. I've learned very heavily on the QWERTY layout. This hurts my brain. Oh boy, that was weird. Nope. Nope. Yep. Yep. Okay, that was okay. Oh boy. Now I do better than ever with QWERTY. It is greater how the usual word endings just make sense though with this. Maybe. Yeah. Where's G? G is where T is. Okay. So T and G just get swapped. So I guess ing would be like INT. Okay. LJT, ing. It does make more sense with the line endings. You probably would not have to move your hand so much. That's pretty crazy. I definitely know this one better, though. It'd take me a while on the other one to get this fast. Oh, it's read. I just read it wrong. That's funny. ZXCV are in the same place, so that muscle memory for shortcut keys does not hurt. That's good. So, can I show me all? So, colmac. Ooh. So above K is U. Crazy. So Q is in the same place. U definitely moves. It's doable. It takes some getting used to, though. Ooh, boy. It took a bit over a month of pain every day, Cyber Patty says. Definitely. It would seem like it would be rough to get this at the beginning. Where's F? Oh, it's where E is. Okay. L is where U is. That's confusing. Floor. I. I is under L. This is amazing. So I get 5 words per minute. That's pretty good. I do a little better on QWERTY. I've never tried Dvorak either. I'm not so great at it. That's fun though. Thank you for showing me that. That's a cool website with all the different layouts. Oh, and there's different variations. Oh lord. Oh lord. Cyber Patty says no problem. That is. Yes. Yes, yes. Alright, streaming for an hour already. Let's continue. our journey, trying to alter these functions so they actually can work. Why are you so mad? Conflicting types. Why? What does that mean? Why are you mad? Too many arguments. There's not too many arguments. There's a new one. Did you forget? Oh, maybe it's forward declared. Yeah, it's forward declared for Codegen expression. Okay, I don't know why I hit build. It's definitely not going to work. Okay, seems I've done it. I now just have to actually deal with it. Right? Where do we effectively need this? Yes, bind the parameters, do the thing. Where are we at? Let's see. So, while generating a function, we would like to enter a context while we are cogenning the expression. So we should use the next child context, and then we should update the next child context to the next child. I don't know. How do we do that? We don't actually have a way to get the next child, do we? Why is this? Why are you mean? No autocomplete? None today, huh? Okay. Parsing contexts just don't exist now. Okay. We do have next child. That is how we do it. So we can just do that. V-me, do we? Do we? Ahoy! How's it going, V-me? It's so good to see you. Thank you for tuning in on this fine morning. Or whatever time it is for you. How's it going, friend? It's just me here fumbling around, making probably the worst code decisions possible. V-me says it's a fine evening. Oh yes. That's good to hear, that's good to hear. So the next child should be set to the next child after we use the next child. That doesn't sound too insane. So the next time we come around, this will point to a pointer which contains the next child. Vimy says, anyways, how are you all, my dudes? Vimy then gives the amazing emotes, Trashed Cat, and the lived fun one. Cyber Patty says, XD Monka S. Lamau. That's not a bad idea. This is actually really easy. We should just do this. Don't we already do it? Yeah, I think we can just do this. We're gonna use it twice anyway. We don't have a last expression, but we can. So we should probably say if last expression does not equal null or something like that, just to avoid a null dereference in case. hey, look, that to do is exactly what I'm doing. There we go. And then I just have to say that. Whoops. Yep. Great. Mucho error. So effectively, I think what we should do is just say use the next child context, but we don't want to dereference it if it's null, right? So we're gonna have to do some fancy context thing. And this is going to equal next child context if it's a thing. So if next child context is not null, we'll dereference it and use that. Otherwise, Landar XT says, just checking in super briefly, so I technically didn't miss this stream. Lamau, it's so great to see you, Landar. You have a great birthday. Vimy says, we should create our own language with blackjack and whores. It's a good idea. Me, Bender, you, we'll go to the moon, and we'll go create our own language. Lamau. Otherwise, just use the context that you're given. And then just use the thing here. No, not that thing. This thing. And then this can just say if next child context do kind of a similar thing. Hey, look. A little better. So now, the next child context should be program children, or no, context children, right? I think that's valid. We can get that down to where we actually use it, because we don't use it up there. And now we have to deal with it. So when codegenning the expression of a function, we pass the next child context in. So then when codegenning a function, we need to use that next child context, which we should. Damn. So we pass in context, which should be next child context, right? That doesn't seem that insane. So we're gonna have to do like we're gonna print the context that we're using and just see what pops out, right? There's gonna be a lot. So, oh boy. So we see using context for function, and it is the top level context. But we want it to point to this context right here, which contains bar and x, which are necessary variables. CyberPatty says, what's a context? Well, a context, if you look up, the circumstances that form the setting for an event, statement, or idea, and in terms of which it can be fully understood and assessed. Basically, it just means the stuff surrounding the stuff that lets you know what it is. So if you know what context is generally, CyberPatty says, thank you. So the context that we're referring to is the context around our parsing, around the current expression that we're parsing, and where it, like what variables are defined in the scope, right? We need to know that. So we need to know which context we're within in order to properly find the proper variables and get the type, and then we can use the type to get the size, and then we can use all sorts of things. It's good. Cyber Patty says, thank you. Of course. I'm happy to answer any and all questions. What is stored in context? I felt that one coming. Where is it? Here it is. A little smaller. Oop, screwed it up. A little smaller. There we go. So yeah, there you go. Here's a parsing context. We have the tree structure. So this holds children, the next child of its parent, and stuff like that. Eternal Wild Fox says, you're talking about scope, but you call it a context. Yes. You could also call it a scope. Or you could call it anything, really. Scope generally pertains to like each of these environments where things are bound. But you could also call this whole thing the parsing environment, or there's a lot of ways you can do it. There's no correct answer, right? It's just whatever works. But yeah, the context contains things that we need while parsing and also in the future while code genning and type checking. So it's effectively just data about the program that isn't in the AST. Parse context preempt. If I am using the wrong word, let's change it. If you can show me something that a definitive thing. Do you only have node structs in your parse tree? That's correct. Only one structure, the node. This is it, right here. This is the entire AST. It's made up of these nodes. One structure. Cyber Patty says that was more of the answer I was expecting. But yeah, I should have seen the Google card, Lamau. I was just messing with you. The Google card was just a joke. But yeah, the context is basically just surrounding our current expression and what we're parsing. The node, to answer Eternal Wild Fox, yep, this is the singular node that makes up our entire tree. So everything here is made up of these nodes. Each one of these, pow, 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 right? Each one of these lines is a node. Okay, okie dokie. So we are using this context for function, and we're using the wrong one. So why aren't we using the next child context? How could it be passed as null? Well, I guess foo is a global function, but we still want to use the child context. So we still create a child context even for global ones. Okay, let's just try it. Maybe I'm very dumb and not picturing the right thing. Because we want to, let's see, what is our, yes, this. So this is our global. And then this is our first child context, and it's a function. So this is the foo. So we do want to, even in global ones, do the thing. So maybe that's just where my error is. Whoops. Eternal Wild Fox says, I have a more complex AST. I have node and number, which makes tree walking more difficult, I believe. Very much more difficult. Using a singular node, you can still have, as I do here, numbers, right? Integers. I have integer nodes, which contain values of numbers down here. So an integer with a value of 2 stored in this node. And I can also have a binary operator with 2 integers as a child, right? So having this singular node that's recursive and can store itself is very, very helpful. But I did notice next child in your node structure, meaning you have a linked list, I believe. Yep, that's how it works. You start with a node, and then to create a child, you just populate children. So program has a children pointer to function, And then function has a next child pointer to this binary operator. But it also has its own children pointer, which points here, which has its own next child, next child. Does that all make sense? Yes, it's a linked list. That doesn't mean it's inefficient, because that's how you iterate and walk over the tree. So it's actually just storing the bare minimum information that you need. If that makes sense. If we did it in like a hash table, it wouldn't really make sense, would it? We'd have to write hashing functions for every single one of our nodes, but then the same node can have different children and be different. So then you have to write a hashing function that hashes not only the node, but also all children. And then are you really that much more efficient than a linked list? Cyber Patty, linked lists in 2022 TM. I hate that meme so goddamn much. I hate it. I don't know why I hate it. It's not bad. It's just I don't like it. Oh, wait, we did it. Chat. We did it. Cyber Patty puts in a kappa on the map. I did it. Hey, Cyber Patty did it. He fixed it for us. Thank you so much, Cyber Patty. But look, we're using the proper context for the function now. Hooray. So now we can find our variable declarations. Where is it? Come on. There we go. Jeez, that took me a little bit too long. Okay. So now if we look at the code, hey, that's a good sign. Hey, chat. We're making space for an integer. Bog. We are making space for an integer, chat. Legendary. Cyber Patty says foggy. So we do this whole section. Done. Alrighty. Now we're gonna have to keep track of the RBP offset. Okay, so our codegen context should contain some data, and it's basically just gonna contain, hey, we no longer need... So this is going to be the actual offset that we use to declare this new environment. Okay, I'm getting it now. Sorry. I'm probably not speaking very well. But effectively, we have a codegen context. Not like that. And it has locals. And we would like to set within this locals codegen context. Eternal Wildfox says, linked list for an AST is pretty useful, I guess. You didn't store a previous for a possible backtrack when needed? Never backtrack. Never look back. Number one rule. No, but you're right. We absolutely could have previous child and have it a doubly linked list, right? Have children and parent. This would allow you to go all the way to the previous child, then to the parent, and that would get you to the parent, right? Of any child. But we never actually do any backtracking. We just save pointers where we need them. Eternal Wildfox says, lol. But yeah, you could absolutely make it a doubly linked list. It would just take double the pointers to do it. So we just store the two that we need. Make it a singly linked list. Sort of. It's like two singly linked lists intertwined with a specific API that to alter them. Eternal Wildfox says save pointers, save memory. Knowledge. Cyber Patty says double the pointers, double the fun. That's a good point. That's a good point. So expression children contains the symbol that we are trying to declare. And we would like to bind it in the locals environment to an integer. Is this how we do this? This is how we do this. An integer with the value of the size of the type? No. We already know the size of the type. We don't really need to do that because we've already done type checking. So type checking should take care of that. Codegen now just needs to keep track of the offset. So this is where that's actually used. And then we update this offset by the byte amount that was subtracted here, which is here. Is this minus equals? It's probably minus equals. Cyberpatty says point. ER point. So we environment set into the locals codegen context the locals offset. So this we're going to have to set for each one that we create, each codegen context. Yeah, so we're gonna have to do something like this. We can either pass it here, or we can just do this for now. And this will be a big to-do, fix me. This is specific to x86-64 right now. That didn't work. Why is that not working? I gotta do that. There we go. Eternal Wild Fox says, oh, by the way, you talked about a hash value function isn't and which you can use to find an address. Isn't and which you can use to find an address not unique for a hash and should show the memory address in C also. I assume just like it does in C# and C++. Yeah, and does get the memory address of a variable. So you're saying you talked about a hash value function isn't and which you can use to find an address not unique for a hash. I'm not sure what you're asking. I'm sorry. I'm doing my best, but I can't seem to figure it out. So hashing, when we hash a node, the node may contain memory addresses that basically are used also by others. So we have like a directed acyclic graph, technically. You get a hexadecimal value from and isn't too unique for a hash. No, because the heap is just a place in memory. So yes, you do have a memory address, but if you can have a single node that points to the same place. If that makes sense. And it wouldn't really help because then if you store it with a hash, you then have to store what scope it's in the value. Does that make sense? So we store all these different things within each environment, within each context. But if we tried to use a hashing function, the actual structure would fall apart. So linked lists kind of help build the entire thing, right? Otherwise, it's not really a structure. It's just a flat list, which you then have to interpret differently. He says true. Yes, yes. But yes, we also plan on doing like directed acyclic graph stuff, where this symbol x can point to the same symbol value as this variable access x, because this string should technically be, it's the same thing. Conceptually, it's the same symbol, so we should use the same symbol. But then that would mean that if we tried to hash these two, we would get similar values. The type would be different, so it would be a little different and it would work, but you can see where that would be the case. And then the hashing function, you can have two functions which have the same parameter declarations, but they're different functions, if that makes sense. So a lot of things break down. CyberPatty asks, do you have any experience with GNU Bison? Other than being scared of it, no, I do not. Pretty good, pretty good. So we're not saving the stack pointer very well, but that's okay for now. So Codegen context locals offset is 32. So then we set this with the locals offset, and then we subtract whatever we have. So equals 32 is probably negative 32, right? So variable declaration. Hopefully we made stack space. Do you have any experience with GNU Bison, CyberPatty? I'm pretty sure it's a parser generator or something of that sort, but I'm not absolutely certain. So it's almost like the locals offset is what needs to be added back here instead of 32. So we may need to remove these from here. So sub this into stack pointer. I guess we're adding, because we're at the end now. And we would like to add our current context, locals offset. CyberPatty says, I'd like to do a different kind of language, and I'm wondering if I should try to first get the grammar down with it before starting the implementation. Never used it either. Well, I'd be very interested in that, honestly. Because I've never used it, so I'd be curious to see if it does help that much to just define the grammar in like EBNF format or ENBF, whatever it is. That's some stream idea. Learning the beast. Lamau. Learn GNU Bison. Oh god. That does scare me. So we keep track of our locals offset, and then we add it back at the end, which means from the footer, we can get rid of that one line. And looking at our generated code, you can see we have some issues, but nothing that can't be fixed. So we'd like to add the negative of a negative number, yeah, to get back to where we are. That's better. So sub 32, sub 8, add 40. That's pretty good. CyberPatty says, I'd need a syntax idea for the language first, though. I do not have anything planned out yet. That's a good place to be in. That's a good place to be in. I recommend just opening a text editor, opening a file, and trying to come up with things. Like, just open, like, temp and go, okay, how would I define a variable? Would I say a equals 3? Would I say integer a equals 3? Would I say a is an integer which is equal to 3? Would I say a is equal to 3 like that? You could say a is equal to 3. You can have 4 equal signs. Like, you can do whatever you want. CyberPatty says just something with a less linear token tree than a Porth-like lang. Yeah, Porth is very much, there's no AST. It's very flat, right? It's pretty simple, which is very nice. So I recommend trying to create like binary operations. CyberPatty says EDs. But yeah, try to create like a binary expression parser. So just create something that, basically a calculator. If it can answer this question properly as 7 and not 8, right? If it can answer 7 instead of 8, then you have a pretty good idea of how ASTs work. Cyberpatty says, I'm pretty bored now after getting it to compile itself, lol. That's a large feat. I can see why you're burnt out. It makes sense. But yeah, I would recommend like a math expression parser and evaluator, so you can figure out how like operator precedence works, and that brings you a lot into like syntax tree programming. But you don't want to parse it yourself, so that's different. But yeah, you could write an basically a grammar that allows for, like, you have to use factors and terms, I believe. But it's doable, it's doable. Okay, so we can now restore a function's local offset just fine. We didn't do it here, though. Function footer should probably be a function that we call at the end of a function definition, but this is fine for now. There we go. Okie doke. Should be pretty good. Pretty pog. Here it is. To do local variable access. So we can do RIP addressing when using global variables. But when using local variables, we have to do RIBUP addressing. We have to do base pointer addressing. Eternal Wild Fox says lexer equals new lexer, 2 times 3 plus 1. Parser equals new parser, lexer. Interpreter equals new interpreter. What answer should it be, lol? It should be 7. 2 times 3 should happen first, you get 6, and then plus 1 and you get 7. Whereas a naive parser would parse 2 times, put 2 on the left-hand side, it would see 3 plus and put that on the right-hand side, so then you would have the multiplication happen after the addition. So you'd get 2 times, in parentheses, 3 plus 1, which would be 8. But yeah, 7 is the proper answer. 8 is incorrect due to order of operations. Okie dokie. So symbol to address, we just want to pass in a symbol. But to get the proper address, we're going to need the codegen context as well. I believe. So the codegen context stores the symbol bound to a stack, a base pointer offset, no? Otherwise, symbol as grid, yeah, so that's all fine. Place that inside there. So local variable access, we're going to need to keep track of the symbol index. It's going to be base pointer address, and it's going to be codegen context locals. We're going to end up needing the environment get from that using our symbol. We have to get into a result, so we're gonna have to do something like this. Node pointer stack offset. Node allocates. And then free stack offset. Okie dokie. We're gonna say if we get it. So we're going to say if we don't get it, we're going to error, which just would return null, I guess. I don't even know at this point. This should be not allowed due to type checking, right? So this would mean that there's an internal compiler error. I hope somebody sees this message one day and gets very mad at me. Why? Okay, so stack offset value integer. CyberPatty says, I have never even had to worry about operator precedence thingies. Yeah, stack-based languages don't have operator precedence. You should worry about it, though. Eternal says, mine works like expression term factor as parsing method. Operator precedence should be correct in my math expression engine. Nice. So that's like the recursive descent style, right? The term factor split up. I can't remember what it's called exactly. CyberPatty says, optimizing compiler would be a nice challenge. I mean, we're gonna do it in this compiler series. It'll happen eventually. Once we get things like programs working and they're too slow, then we'll optimize them. Eternal said, I would love to allow unary operators also, so I can type 1 plus -1. Something does not work. Unhappy face, says CyberPatty. Eternal Wild Fox. Yeah, that's a great idea. I think you just have to treat a unary operator as a null denotation, the same as a number, and it would be fine. Eternal Wild Fox says, yeah, my parser is LL recursive descent. LL of 1. Nice. Very nice. So we write the stack offset here. I guess we just have to try it. Symbol to address. That was it. Okay. That was rather simple. So now in foo, what do we have? Okay, also we can get rid of using context. I think this is always gonna work. What if I just do this? Because I've changed the semantics, no? Oh, did I changed the wrong one? I see. Interesting. So that's fine, I guess. CyberPatty says, my parser is O of bad. Eternal Wild Fox says, lol. CyberPatty says, got 4 out of 5 out of the compiler time, though, just by flushing the assembly buffer every now and then. 1 megabyte of assembly is no joke. Why are you generating that much assembly? What program are you parsing? Is it like, does it talk to the gods? Are you Terry Davis? Like, what is up with that, man? We should have a variable access within here. We literally just don't handle access anywhere here. Okay. A little interesting. Okay, variable declaration. Variable access. So how do we do a variable access? If it's a global variable, we should handle it here. Otherwise, it's a local variable. CyberPatty says, the compiler! Still less than Porth. Lamau, you're correct. So CyberPatty generates a megabyte of assembly compiling the compiler, because it's self-hosted. Eternal Wild Fox misunderstood slightly. Said, you're writing a compiler in assembly? Oh my god. CyberPatty says, nope, I wrote compiler that generates assembly that compiles to the same compiler. Yes. Self-hosting. Okay, so for a global variable, so a variable access will return a value. It's an expression, so we have to get a result register allocated. Yes. How do I do that? Okay, I'm gonna steal this for an integer. And I would like to move the rip addressed string into the register name of the result register. Yes, so we will allocate a register to use for this variable access return value. We will return right into this register the memory address of this variable, which the memory address of this variable should just be the child value symbol. So now we should be able to access global variables. Should we just try that? What are we doing? What is this? This is math, isn't it? So global variable x, and then x. Ooh, I broke things. Okay. That did not quite work. What about z? Does it have to do with the name being the same? It doesn't. We just break things. So a variable access at the top level tends to break things, so that's good. We should probably figure out why that is. Right? Because we get all the way here. I mean, we should get here. I don't know. There's probably a giant bug here that I'm not seeing. Or context. See, context, we use the iterator. I don't know. Variable equals node allocate. Free variable. Do we even use variable? What do we use variable for? Environment get variable symbol variable. So this should be the type symbol. This is confusing. What am I even trying to do here? This is why you write comments, folks. So we're looking through the parsing context for a variable. Okay, so this is ensuring that the variable exists. And otherwise we say, hey, this is an unknown symbol. But look, we'll never get here because context iterator was incorrect. Haha. Still has nothing to do with that, but hey, hopefully that's better. Ugh. Alrighty. Hey, my internet just took a big dip. Wonderful. Eternal Wildfox says, I'm still not sure if I should go for CMake or pre-make. CMake is like an industry standard. You'll find many programs that have CMake. I've never seen one program that uses pre-make. I don't know if that should influence you. I'm just stating facts of my own experience. CyberPatty says, no, for fuck's sake, I reloaded and lost this quality chat, Kappa. Lamau. Eternal Wildfox says, CMake is battle tested, pre-make is in beta. Exactly, yeah. CyberPatty says, just go against the mainstream. Lamau. I mean, pre-make is fine, it's just Lua. There's nothing wrong with Lua. It just seems like it's, you're not gonna have as much help writing pre-make versus with CMake. Because CMake has like millions of users all over the world that can help you. Where pre-make has like thousands of users spotted around the globe occasionally. So it's going to be a little harder to get help. But it's not a big deal. It's just Lua. So if you know Lua, you don't really need... You know what I mean? Da-da. So we can create a variable access of a symbol, and it just so a variable access contains the symbol directly. So what we just wrote may break things because there isn't one. Well, that's much better. Could not allocate register. Hooray. So we never actually free this register. We allocate it, but when do we free it? CyberPatty says, yay. We did fix it. We fixed it. We just, we were using the child where we actually store the symbol directly in the variable access. Because the variable access just has the symbol as a value versus having a child, which is a symbol. So that lets us save a little space. Be a little simpler. So our global variable has been dealt with, it seems like. See, it works. It works. And if we use as, hopefully it will accept this. As accepted it. Now we can use LD and compile that. Okay, and that worked. And then we can run code.exe, and it failed with code 29 because we didn't generate our exiting. We never ret. we have some issues here because we ran out of registers to allocate. So running out of registers to allocate means that we got to add more registers to allocate. My child is symbol too. They should hang out. Hey, my kid's a symbol. Your kid's a symbol. We should hang out. It is funny talking about parents and children so much. You start to forget what the words actually mean. So we're gonna need this either way. Just to be clear. But this is going to be BP, and this is going to be LLD. Do I need $1 here? I don't think I need $1 here. We'll have to see. Expression value symbol. Why are you mad? Because this is not an integer. So our integer is actually going to be our codegen context. If we get from the environment what we need, the codegen context, what are we looking for? We are looking for a local variable at the ID. So the ID is the symbol that we are looking it up under. So that would be expression, would it not? Hopefully. And then we need a result. I think we have temp node. And we can say if we find that, go ahead and break. Codegen context equals null. Printf, another internal compiler error. So we're gonna error prep and say, hey, we can't do this. Error, this is just a generic error, and we say, could not get local base pointer offset of symbol, of variable access. Sure, why not? And we'll print out variable just to do it. Alrighty, and this will be expression value symbol. So this would mean it's not found in any codegen context environment. And here's the thing, we're gonna have to keep track of the offset as we go. So it's gonna equal 0, I presume, at first. But here's the thing, when we go up into the next Codegen context, if we find it within that. Okay, so to do, to do would be store base pointer offset from global offs, from parent base pointer offset, if possible, right? Because this would allow us to access any local variable in any parent scope. There we go. For now, we can't do that, so we just have to do this. Get it from the current scope, please. Okay, so if we do not find the variable, for now we're just going to say this. Right? This is fine. We're going to move this one up here, because why not? Alrighty, so the idea is get the local offset into temp node, and then go ahead and use temp node to do the thing. Could not get local base pointer offset of variable x, and also could not allocate register. We have 2 errors. How beautiful is that? So we have a variable x. Variable x in this. X should be in the current scope. It should be fine. Take away that variable declaration, hopefully to free up some registers. Still could not allocate register. Variable x. So this access is having issues, which is interesting, because you think it'd be fine, considering the context and all. So x was never actually defined as in the locals because it is a parameter. So in a function, the parameters, or excuse me, the arguments should all be set in locals, no? Yes? So why does this not work? We set it in the Codegen context after creating it. We still could not get local base pointer offset of variable x. So what Codegen context are you searching within, young Padawan? It would be searching, hey, first time chat from a new viewer, how's it going, Chaser HG? Chaser Mercury? With a seems good emote? How's it going, Chaser? What's going on? What brings you into this compiler stream? So maybe expression is the problem. Maybe I need to do the same thing. Can do this. Yep, now we just run out of register allocations. Could not allocate register. So the reason for that is we never free a variable a variable access, because we're just allowing a variable access at the global scope. So if it's a global variable, we don't actually need the register, do we? So this variable access is an expression. It should be handled. So in which way is it handled? Because when we have an integer, so if we just wrote a bunch of integers in a row, we'd have an issue. Because we just keep allocating registers, but they're not used in anything. Right? So the idea is every time we're done with an expression, we should free its result register. Yeah, it's going to be rough. That's what we do for the binary operator, so it does make sense. This seems like the function, and this seems like the global. So in the global scope, if expression result register CyberPatty says welcome. Have you tried carbon by any chance? I have not tried carbon. Eternal Wild Fox says carbon. Oh. Oh. Have you tried carbon, CyberPatty? I'm not into those syntactical languages. They're too complicated for me. This isn't how that works, though. So we're just going to say register deallocate from R the result register. Hey, look, it worked. What happened? All right. Ha ha ha. This ain't so bad. So 16 from RBP. How did we generate this? Right? How did we generate that? CyberPatty says I could try it with new compiler project. Oh lord. Or I could just use Rust and drown in GitHub stars. Lamau. Eternal Wild Fox says Rust is overrated, but I never used it. CyberPatty says I know, lol. I've used Rust and I don't recommend it. Feel free to use it yourself if you're smart enough to use it. I feel like I'm too dumb to use Rust. It's made for people smarter than I. So when calling foo, we should set the stack up so that the base pointer, so 8 above the base pointer will point us to whatever's on the stack, which would be, that would be our, so what would be on the stack? What's on the stack when you by call? We have to check out call. Eternal Wild Fox says, I looked at the Rust syntax. I did not like the syntax. CyberPatty says, I am also too dumb. It just seems like there's so much to have to know that hasn't been done before in any language that it's like, and then they're so pretentious and they're like, oh, you don't know what to do? Read the book. And it's like, well, the book has one sentence on it and it makes no sense and it contradicts these 3 other places. So I don't know what to do. And then they're like, just read the book, man. The book has everything. It's like, I don't believe you. I don't quite believe you. So how does a function, let's just do it in the compiler explorer. Why not? Right, so now we have foo. I'd like to call foo. And if foo took in an integer x, and I pass in 5, why? Oh, it's int. We're in C. Alrighty, this is looking pretty good. Eternal Wild Fox says, lol, they say RTFM. They do quite literally say RTFM. That is a fact. Another king idea for a stream. Memory safe seg faults. I don't even know what that means. Can you seg fault in memory safety? probably using Rust, I'm sure. So the problem is these aren't stack arguments. These are arguments passed in registers. So saves PL procedure linking information on the stack and branches to the called procedure specified using the target operand. The target operand specifies the address of the first instruction in the called procedure. The operand can be an immediate value, general purpose register, or memory location. View assembly documentation. Okay, this is cool. This is exactly what I wanted. Perfect. But that's a great idea, CyberPatty. Memory safe segfaults and learning GNU Bison. We should write those down. So we can do near couple. Yes, bunch of them. Cool. This is effectively what we're doing. So we push the instruction pointer on the stack. The processor then branches to the address in the current code segment specified by the target operand. Yes, the target operand specifies either an absolute offset in the code segment or a relative offset. So you can either use RIP addressing or not. Yes. Alrighty. That looks pretty good. So effectively, we're going to have one thing on the stack. So when we call foo, we're going to have the return address on the stack. So wherever our instruction pointer is that we called from, like the address of the next instruction, if that makes sense. So if we were to call foo, I can't do it really there, but call foo like here, this pushes onto the stack the address of this instruction. CyberPatty, generating memory-safe.y files for GNU Bison with Rust. That would get them clicks. Lamau. Alrighty. I got some phone thing I'm answering. One moment. Alrighty, that's me done. Sorry about that. Dead air. So when we call foo, if we were to push the argument, right? Like push 5. Eternal Wild Fox says, how did your node struct look again? You have a number value and a text variable in the struct, if I remember correctly. Oh, mine English is out the window. You sounded pretty good. It was like very southern. I've seen people text like that. So we're looking at the node struct is what you want to look at. Here it is. So the way we do it is we use a union, which means that it's a singular place in memory. See, it's 8 bytes, but it contain either this type or this type, depending on which symbol you access. CyberPatty says, where are you from, dude? I'm from the Pacific Northwest. Let's go with that. So like northwest of America. Nothing interesting here. Generic American, right? America. Yeah, America. So 16 from the base pointer would be the base pointer here, past RBP, past the return value of the call, and then that would actually reach the pushed arguments in reverse order, right? I don't know if we have the reverse order thing down, but hey, it's working. It's not too hard to reverse something. Eternal Wild Fox says, never heard of union in structs. Have learned something new again. I see, yeah. So a union is just another type in C, right? So this node value could be defined here, like this. If that makes sense. And then we could just have node value. Like that. So then this value could be an integer symbol. We just had the inline so that the definition just plopped in right here. That makes sense. But yeah, unions are allowed within structs because they're just another type. It's very cool. Okay, so this should be correct. And then we would just have to dereference wraps effectively. Eternal Wild Fox says, I don't know if C++ allows it. It definitely should, because it's kind of a feature. Just the union will take up the size of the largest type within here, which memory addresses and a long, they're both the same size, so it's 8 bytes either way. But if you started putting in like a node in here, right, and just put it in literally, there'd be a bit of an issue in that you can't use an incomplete type within a union or a struct. C++ is a superset of C, so it should. Exactly. But yes, yes. So now, we can access the memory address of a variable, which is pretty powerful, I would say. And we say, so for global variables, global variable reassignment is what this is. Eternal Wild Fox says, I will check my C++ book of 800 pages. Oh lord. Cyberpetty says, I'm gonna compile my C codebase in Carbon, Kappa. Lamau. So variable reassignment in nested places. And all we have to do, isn't it a very similar thing? So we have to code gen the reassignment expression. And then we have to get the register name of the result register that was used. We use this register name Cyberpatty says, what do you do in life, by the way? Full-time streamer? Easy money. I'd like to keep most of my real life private. If you know someone's work, it's very easy to find them and their address and things. So nothing like that. But I can tell you that it's not interesting. I mostly sit at a desk. What I do at home is much more interesting in the coding and creating things in the backyard like a maniac. Cyberpatty says, easy money. Yeah, I wish it was easy money streaming. Eternal Wild Fox comes back. He read through the entire 800 pages. He says, yeah, C++ also allows union. That's awesome. I would expect so. Okay. That's a little funny. So we move 3 into racks. But then this moves... I don't think this is right. We have to do an indirection. Eternal Wildfox says, no, I looked in the index of the book, talked about it. Nice. You were able to jump right to it. You just said, I'm going to look in this 800-page book, and then came back in like a minute. I was like, that's impressive. You read it all. Cyber Patty says, right, I appreciate your privacy. I won't social engineer anymore. It's all good, my guy. I don't mind questions like that. I just don't want to be doxxed or swatted or you have my phone number leaked. Having to change my phone number is a real problem. So I just don't want to do these things. But yeah, it's all good, Cyber Patty. Don't feel like you have to not ask anything. If I don't want to answer something, I just won't answer it. It's all good. Because I don't even have to read the question out loud, right? I'm okay with sharing anything I read out loud on stream. Alrighty. So we can get the address of the symbol given our current context for a variable reassignment. So when we move a register into an address, how does that work? Does it write the value of the register at the address? Does anybody know? I believe that's what it does. Nope. Just move, please. M? No? Okay, here we go. So move has a whole lot of operands, but we're looking for a move from a 64-bit register to an immediate 32. Move immediate 32 sign extended to 64-bit. Okay, so this is Intel syntax. We're going right to left here. So we want R64 on the right. Yes, here. Move R64 to R/M64. Wonderful, helpful. They really need examples on this website. That would make this kind of perfect. Okay. Alrighty, so moving the register into the memory, well, we're just going to say it writes for now. So hopefully this would work. And let's think about what this says. So this says racks is 16. Yep, that's where it would be if we called the function. It would be 16 above the base pointer, blah, blah. And we move into, so we return the value there after writing 3. So foo should write 3 here. This sub 8 is for bar, and then we add it all back, so it should be fine. Let's try and do something like that in main itself. We're going to say z is an integer. Z is assigned to 69. And then we're going to try and return z. Hello? Did this not update? Hello? What happened? What went wrong? That went wrong. We didn't parse? Oh, Christ. Something screwed up. Damn it. Why is it not? Why? If I put 2, will you work? Yep, so we're missing one. So what if I put y here? I just want to make sure we're getting the right one. So interestingly enough, putting y there made all of them go away. And we got symbol sim_y printed out. So that's probably not the best. And we have invalid syntax unknown symbol. Okay, that's fair. So let's think about a valid symbol then. We'll go A, B, and Z. Why not? We get A and B, but not Z. So we're not getting the last expression. It's not working. That's an issue. That's quite an issue. So variable access, last expression. Am I supposed to continue here? Like, I'm not sure. Because then we should look for an operator after finding the variable access. If we don't find one, then we'll just break if we're in the global context, which means we return this variable access. And it's already written to. The working result has been, so... Something breaks here. I don't think something breaks here any longer. But there is a to-do. Last expression of file is kind of just ignored for some reason. Easy, AS. Easy as, ABZ. That's right, that's right. So we're going to say A is assigned to 420, B is assigned to 42, the answer to life, meaning of the universe and everything. Now variable access of B. Okay. I don't want to return 42. Let's put Z here and B here. Alrighty. So the idea here would be that, yep, we're just allocating and deallocating this register because we're not using it in any expression. And, yeah, yes. So now, compile, link, and run. Hey, haha! Our program exited with code 69, which is exactly what we set Z to. So if you pretend that we parse this as the last expression, just ignore that down there, you can see that Z is the last expression in our entire program. Z was assigned to 69 last. So now we can run that, which generates this assembly. We can then assemble that using as. We can then link it using LD, and then we can run it using Microsoft Windows, ROS. And it fails with code 69. So if we were to change the value of Z, let's say to 69, right? Then recompile, relink, and run again, it's now 57. Well, that's not right. But that's because you can't have numbers larger than 1 byte as your return status. So this would have to be something like 69. We can't really do much, can we? Let's just make it 120. It's not funny, but it does work. Shell command failed with code 120. It works, it works. CyberPatty says, would the assembly break if you would initialize variable with same name in multiple functions? No, it would not break the assembly because they're scoped. Everything's scoped, my dudes. So CyberPatty, I think your misconception is like, if we defined x as an integer in the global scope, right, here, we will still be able to assign to this x from here. So this x integer parameter will shadow this global scope, if that makes sense. So if we were to add it and say it wouldn't be assigned to 3, it would be assigned to 0 or whatever it should be, right? Let's just make it 7. You can see we failed with code 7. But it doesn't break the assembly at all, because we don't generate RIP addressing unless it's a global variable. And if it's a nested scope variable, like not global, it's a local variable, then our addressing is all of a sudden our BP, and we use this, this different syntax to address it. How are scopes defined in the assembly in your language? Well, okay, let's go show you. In Codegen, we have this symbol to address function. CyberPatty says, yeah, right, thanks. Yes, but we have this symbol to address function. So we can pass in a symbol and our current Codegen context, and it'll say if it's global, we'll just use the symbol and RIP address it. Because the assembly, we can just allocate memory address symbols directly. So we just pass the symbol we use directly through to assembly and allocate space in the data section. But that's only for global variables. So if it's not a global variable access and it's local, also this is done, then we use the stack offset from the Codegen context locals environment, and then use the absolute addressing from the base pointer. Hopefully that helps. But yeah, so you can see that the foo call itself will push 8 bytes on the stack. So the arguments will be 8 bytes above the foo call, the base pointer here, but then the base pointer we push RBP, so then the stack pointer is 16 bytes below the arguments. Then we set that as our base pointer, so our first argument is at 16 bytes. CyberPatty says helped. Yay, I'm glad it helped. And then this is where bar is right now, and it would be accessed with -40 RBP. If we ever did a variable access on bar, we could test that. So bar is a function, so if we try to access it, we still could not allocate register. So in any case where we don't handle an expression's result, we're going to have to do that, which is going to be killer, but it's fine. That just means that in functions, I screwed up a little bit. In functions, oh, okay, I have to go below. When we're defining the body, we have to do the same thing as before, and free the expression, because we don't actually free the expression's result register, because we don't actually need it any longer. That's much better. Yep, there we go. I think this is, we need to subtract then do it. So that would be in our local variable declaration. That's a variable access, is it not? That is. So declaration, somewhere. Where are declarations? So they're going to be within Codegen expression. Okay, then I'm going to have node type bar decal here. And we don't do variable declarations at the global scope because there's nothing to do for them. CyberPatty says, I still have some struggles with the AT&T syntax. Yeah, I used to, when first getting into assembly, it is rough. All the different syntaxes and stuff, but it really is simple if you start to remember the source and destination operands and their positions, rather than saying, oh, the first argument is this. Because GCC, AT&T syntax uses, is what we're using here. So with AT&T syntax, you have your mnemonic. Is that how you spell that? Your mnemonic. Then you have your source operand, and then you have your destination operand. So this is AT&T, right? But for Intel, it goes mnemonic, and then destination operand, source operand. And the real issues arise when you use something like imul, which has a source, a destination, and a target. Ain't that fun? So I don't know imul on Intel and AT&T. I still would have to look this up specifically for the case I'm using it in, because having 3 that I have to shuffle around in my head based on what syntax I'm using does not go well. But having the 2 I can remember pretty well, like, oh, in AT&T, use percentage before a register and use dollar before a literal. Otherwise, it's a memory address, right? And you can use these parentheses to dereference a variable into a memory address, but we don't actually do that anywhere. We just use relative addressing. CyberPatty says, oh, well, that's the thing that screws my tingle. Exactly. It's like there's so much to figure out. I read the shit the wrong way. I still do. It still happens. Like when if you go back a few streams when we were doing codegen for binary operators, I got confused on like, wait, does subtract have its destination then source or source then destination? And I got so confused that I actually didn't do it during the whole stream. I messed it up. And then I had to fix it afterwards, which is really funny. It was like, I don't really know what I'm doing. Oh, but we have to do this first. Okay. There we go. So now, if you have the base pointer here, and you subtract 40, you will get the bottom of this allocation, which means that accessing the next 8 bytes as an integer would be totally allowed, or a function, or whatever. And then we move bar into the result register, which is unused, so we just continue overwriting it as we go. Very cool. Very cool. And this just passes x after assigning 3 to it. Oh my god, it's working. So now function calls we're going to have to deal with. So the idea would be to push arguments in reverse order onto the stack. Sure, so the first argument will be 16, the second argument will be 24, if they're all 8 bytes and such. Okay, so push arguments in reverse order onto the stack. It's call. That's kind of it, right? So we have to loop over something, right? What do we have to loop over? We have a function call. So here, I want to comment this out. Oop, and also break this so we don't break things. CyberPatty says, I see there are so much things I want and should learn to do with a more traditional language rather than stack-based. Absolutely. Stack-based languages are like a whole different paradigm on how to use the underlying hardware because there are stack-based machines, right? So there are literally entire machines that are built to deal with stack-based programming languages and stack-based assembly and all of that, right? Whereas the x86-64 architecture is not made for stack-based programming languages, and there's so many different ways that you can use it that some people can write assembly like Corth and Porth and things like that. Torth, right? We can write assembly that turns our x86-64 architecture into a stack-based machine. But then we can also write assembly that turns our x86-64 architecture into like a what is it? Oh man, I'm blanking on the name. Not the Turing guy, the other guy. But basically, it makes it into a Turing machine where you can have an infinite series of bits and operate on those, or things like that. So you can use the same assembly of x86-64 to accomplish all these different tasks. It's very cool. But yes, you see that there is now like so many worlds, so many paradigms you can use to generate assembly and actually use the computer that is in front of you. It's so cool. I love being able to understand, like, that's how computers work. I understand it now. It's not like magic. It's not like, ooh, scary. It's just like, oh yeah, that's how computers work. I get it. So while temp node isn't equal to anything yet. It's just equal to a node. So we can't really update temp node as an iterator, right? So we're going to have some iterator, and it's just going to equal null. And then we'll say iterator equals something. So a function call, that's why I wanted to do this. I think I should do a simpler thing. And then let's call foo with 25 and return A. We're not going to worry about return expressions yet. Not there. It's probably, we may already handle it, but we're not there yet. Invalid syntax. Function definition requires return type annotation. Yes, it does. Redefinition of variable. Oh, yeah. We can't have an integer a and then an integer a. Can't name a variable the same thing as a parameter. CyberPatty says, but I think I would have no chance of learning compiler concepts without the adventures of some linear token tree stuff. It was helpful anyways. Absolutely. If I didn't make Korth, I probably would never have made Lenser OS. Korth showed me that, like, okay, the low levels of the computer are not like some hidden black box that are not known. There's just manuals, like literal entire hundreds of page manuals on how your computer works and what each instruction does and its control flow and what it might do and what it might do in 32-bit and what it might do in 16-bit and 64-bit. And once I figured out all this knowledge was just like available, I was like, ooh, I'm doing it. I'm gonna do it. And then seeing Serenity OS was awesome. It was like, okay, one person can make something. One person can make a difference in programming. Because I didn't know. I was like, an OS seems like way too big. I'd seen like tutorials on them, but I didn't try because it's like, it's an OS. I'm just a guy. I'm not Microsoft. But then seeing that, it was like, oh, one guy can make an OS in like 2 years. So how bad? Why not start now, right? We'll just return A. So CyberPatty says, and yet here we are creating compilers. Exactly, making the difference. Lamau. Eternal Wild Fox puts his tongue out. Lol. We're all having fun. So we get a function call foo with an int 25. Our variable access is done. So interesting. So just variable accesses aren't caught. It seems to be just variable accesses. What I really need to do is write an emacs mode for this language so we can start to get some nice syntax highlighting. It's going to be dope. I should use tree sitter or something. So we're not calling foo. Why are we not calling foo? Because this function call has its, okay, so children next child. CyberPatty says, oh well, it's bedtime in the north. Naughty naughty, heart. Oh, I love you, CyberPatty. Thank you for watching. Hearts all around. I really appreciate you coming out. You were so positive today. I wish I could speak. You were so positive today and it was so much fun. I really like every time you end up in the stream. So thank you for coming out. Get some good rest. And we'll still be working on this epic compiler. Eternal Wild Fox says, I never used linked list before as I never needed them, so let's try. Yeah, that's exciting. Linked lists are where it's at, baby. So each one of these is an argument. We're going to have to reverse a linked list, which is going to be annoying, but it's fine. CyberPatty says, epic. See ya. Bye-bye. Bye-bye. All right, so we have iterator next child, because iterator needs to equal that. So then let's just print the iterator and see what we get out if we can. So Interestingly enough, I don't see us here. Oh man, my voice is going out. Sorry. Oh, here it is. Int 25. So this is literally just the expression which we need to code gen and then push. Okay, yeah. So we need to code gen the expression recursively, of course. Eventually, this will all be changed, I promise. Yep, pass it all through. But we are not code-genning our current expression. Eternal Wildfox says, I wonder how you would do operator precedence, them as binary trees makes them easy. So I want to show you, I'm going to draw you a picture. Is that okay? I'm going to draw you a picture. And effectively, what I'd like to show you is that our current node structure has a pointer called children. But it also has a pointer called next child, right? So how this works is children, here's how we'll do this. Children pointer is represented as like this little symbol, and we'll have next child implemented as an arrow. Does that make any sense? So like the children pointer will be this symbol. So if we have a binary operator, like plus, right? Then you can have a single child under children, which would be like integer 4, right? Or something like that. But then you'll have from integer 4, next child will be set to another integer, and that could be like 2. So this would be how you could do a binary node using our two little linked lists. But then, if you wanted to add another child to each of these nodes, you can do it. So this could become a binary operator node with minus or times, right? And then you could have more children coming off of here, if that makes sense. So we do two linked lists with one that starts it and one that continues it. That way we can have children have more children and not have only a singular flat linked list, right? So binary operators are still binary tree nodes. It's just only they are, because these integers will just have null pointers here because they're not there, right? So with a null pointer, you don't have to worry about checking children that aren't there or ensuring anything like that. And what this also allows you to do is have a program node, for example, that contains a binary operator or something like that, and then it can continue to point to other expressions. So then the program can contain any amount of expressions, and you can have things like arrays, like array, right? Could just be something like this. And then you could have any amount of children that you want in the array. So it allows, it's a very flexible move, if that makes sense. Hopefully that made any amount of sense. But yeah, we kind of have two linked lists within each other. So program children is binary operator. Binary operator next child is null, but binary operator children is binary operator of multiply, and then binary operator children is integer 4, and the next child of integer 4 is integer. And that allows us to do this type of iteration where, oh Christ, this type of iteration where you get the first child, right? You just need the first child, and then you can continue on with the rest of the children in this way. I would have figured they need to use nested linked lists. You absolutely could. So you absolutely could have like this sort of is a nested linked list, right? Because children can contain more children. So children, 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 if that makes sense. And the next child linked list is nested within each child. So this next child linked list is here. It just goes to null here. Hopefully that makes any sense. But yeah, there's a lot of ways you could do it. This is just the way I did it, so that I only have to use 2 pointers and I never have to deal with anything else. In C++, you could even use references and it'd be better, but they kind of have to be null. But if you use references, then they would just be set to none nodes in case that you don't use them. So we cogen the expression, and then we would like to register deallocate from R the expression result register, but we don't want to cogen the current expression. That's what we're currently doing, and it's a function call. We would like to cogen iterator, and then free iterator after pushing it onto the stack. So we have iterator. What do I want here? So I'd like push, and I'm gonna have to use the register name of the iterator result register. And I would like to push that into, just push that onto the stack, right? I think that's fine. And then as we go, we can say deallocate that register. So we can push, we fill this register with the expression, we push it, and then we deallocate it and go over again. Then we just emit into code, call, and this would call the children value symbol. We're just going to try that out and see what we generate. That doesn't look too insane, does it? So then we would like to say, is a function called destructive? Should we allocate a register? Should we allocate a register as the return value of this function? I don't think that's how that works, because we can't control where the return value will be. It's just going to be in racks. Well, we had an access denied. Okay, this is good. This is good. We exited with code 5. We should have exited with code 25 because we call foo, in which case racks should be set to 16 RBP, right? So it should be set to A. But this is a memory address. So racks being a memory address, then when we go back, that shouldn't be a big deal. Everything should be fine. We definitely need to pop all of these though. Not pop them because we don't need them again, but we need to fix. So we're going to say, what do we need to do? So we need to push all of these as registers. That's doable, I think. That's not too insane. Alrighty, I've been streaming over 2.5 hours. Be sure to hit that Discord down below. Check it out where we all talk to each other. We make announcements every time I go live. And there's a text channel where we all have a lot of fun and help each other out. I very much recommend it. So please join, please join. There's also the YouTube down below if you want to check out any previous broadcasts. And then there's also the donate button if you would be so kind and so generous. I appreciate any and all donations that come in. It will help me continue this epic business we call Twitch. And hopefully it'll let me not ever have to activate affiliate, because I don't want to deal with taxes and getting 1099s from Twitch. I just want to deal with donations because I can I'm basically self-employed. I still am through Twitch, but it's different. With the donations, I'm able to deduct all the bank fees, whereas with Twitch, I just get paid less. So donations help me out in a lot of ways, and I very much recommend that if you can. If you can't, don't feel bad. Just hang out, have fun, and enjoy what you are watching. I appreciate you just as well. In that case, after we do this, we need to count how many we pushed, right? So we're gonna say, okay, we need some count. This sucks, but it's fine. Count. Count plus plus. Wow, count. Count minus minus. Can probably just do that. So while it's greater than 0, well, I don't need to do something for each one. I just need to add some number into RSP, a literal number, and this number is going to be count times 8. I don't think that's too insane. I think that's how that should work. So that after we push racks, then we call foo. The stack pointer will be back here, so we need to pop racks off like this. I think that's fine. Does that break things? Hey, we did it! Holy shit, I did not expect that to work. Oh my god. Hey! Bog. We called a function. Boys. Chat. Boys and girls. All genders. I'm just excited. Oh my god. We actually compiled this program. Oh! Oh! We compiled this program into this assembly. Right? This is so cool. We compiled this program into this assembly. We use as to create an object file. We use LD to link the object file. Then we run the program and we get code 25. So foo is properly returning the past integer. Oh! Oh! That's exciting. I'm happy about that one. I didn't think we would get this done today. I was kind of frantically working because I don't have much time. But oh my god. Pog! Eternal Wild Fox, give us the pog! Yee, give me that pog! Oh, this is all of us. We all did this together. This is beautiful. Oh. Oh! This is so pog. We actually wrote a function in our own language, called that function with an argument, a type-checked argument, and then returned that value from the program. Oh my god. I don't know why I'm so excited, but I am really excited about that. That really grinds my gears, if you know what I mean. Oh yeah. That's Pog. So now if we were to call this with 50, what do we get? What do we get? Hey, we get code 50. Hey, that's Pog. So, what if we were to try something like this? This is a little scarier, right? Exited abnormally. Mismatched types. Oh, that's fair. So we actually have to be able to type check binary operators with variable accesses. Ooh. Man, we are making progress. This is Paug. This is so Paug. We are actually calling functions now. This is incredible. This is so incredible. Okay, so the idea. Ooh, that's a bug. Hey, look. That's a bug. Yeah, you're not allowed to do that. Woo, Good thing we fixed that, huh? That would have been confusing. So we were reassigning iterator, right, to all these different pointers, and then we were just freeing it at the end. So we were just freeing some random node within our AST while we were type checking it. Oh, Christ. Well, fixed now. Okay, so what are we doing? We're type checking an expression, and it's a binary operator. We try and get the expression return type of the left-hand side. And if it's a binary operator, if it's a function call, we do it. But if it's a variable, okay. So now we can do a node type variable access. Oh boy. So to do is going to be get type symbol. Is that what we return? No, we return an int. So we have to get type symbol from variables environment. We then have to, what? I'm just going to keep it like this. Get type symbol from variables environment. Get type integer. We should probably have a better name for this, but get the integer, like the actual value of the type, from types environment. Using type symbol. Using var symbol. Then, I guess we just return that. Then return that. No, so then we just say like star type equals that. Okay, so we will look in environments like this. So this searches all parent environments, all current and parent environments for functions. But we'd like to check for variables in a very similar way. We should move this little pattern into its own function. In any case, we then need to do the same thing. And that's going to require the iterator type pattern. Okay, those are all context iterator. Okay, and then copy this line. And then go create context iterator where we can. So we did it differently before. We used original context and restored it. That's not a bad idea. We'll just do what we did originally in the other one. We don't need to have this pattern. We already changed everything, but that's why you should look ahead. Don't be me, right? And the idea is that context should equal, whoops, the original context. So we can restore it to what it was here. Hey, Maconate! Hi, Lens, and hi, chat. How's it going, Maconate? It's great to see you. We are working more on our epic compiler. Did you know that we have function calls now? So this program, with foo, we can't do that yet, but with foo, it returns an integer and it takes in an integer, so we can call foo with a single integer, and that is what will be returned from the whole program. So then if we go assemble this, link it, and run it, shell command failed with code 50. So that's exactly what our number is here. And if we put in 69, shell command failed with code 69. Hey! Yes, we have done function calls. So cool. So now, a variable access, we should say, if not context. We need to like return error or something. Yeah, break. So when I break, I return error anyway. So we just need to error prep. Error. Error, what is this? Generic, and say, could not get variable within context. Or variable access return type. Why not? Alrighty. So we prep an error and then return it. Macronate says nice with a thumbs up. Yes, yes. We are making so much progress. We're now type checking variable accesses. Macronate says I'm fine. Sorry if I did not ask. Or I did ask. I don't even remember at this point. But I'm glad you're doing fine. We're doing well today. I am very glad that you chose to tune in and see some compiler nonsense. Okay, yes, let's do the same thing here. Could not get type within context for variable access return type. Sure. And we're just going to print type like this. And this will print what? Result? No. What is type? What type can we not get? It would be result. Hopefully it works. And then here, this would be variable. Alrighty. This is not too bad, not too bad. So this variable access contains a type, a variable symbol. So then we have to get that variable symbol in the variable's environment, and that gets us the type symbol. So now result should contain the type symbol, right? And then we should say with the type symbol, look up in the types environment. But don't look up expression children, look up result and write into result. I don't know if that's going to do so hot. So yeah, let's use temp node here. I went too far. We're going to write into temp node. Well, actually, yeah, we'll just do it this way. Hopefully I caught all of those. So we write into temp node. Then we use temp node as a lookup in the types environment for result. And when we get that, that is when we should say, hey, we have succeeded. So we need to set result type. But result type should already be set, so we kind of just need to break. So now if I go to simple and write a plus 10, could not get variable within context for variable access return type, and variable is null. So hey, we're doing pretty good. And I know the issue I made, I believe. The expression is a variable access which contains a value symbol of the variable symbol. Hey, look, it worked. Did it actually work? What did we do? So now we get the memory address into racks. We add, does this get, this probably reads. So this gets the value of our variable into racks. We get 10 into our 10. We add into our 10 racks. And then we move our 10 into racks for our return value of our last expression. Oh my God, it worked. Chat, oh my God. No. Look at this, shell command failed with code 79. I mean, I'm not a smart man, but 69 plus 10 is 79. Is it not? Is it not? So we can use as to build, LD to link, and then run the executable, and it's 79. So what's 10 plus 10? It's 20. Give me that. Oh, it's 20. Oh, it's 20. Oh! Yeah. Eternal Wild Fox says lol. That's just, it's exciting. We're calling functions that are altering arguments and then returning the values based, like functions are working. This is incredible. I did not think we'd get here today. This is amazing. We still need some parsing troubles. Hey, look! That's what we did today. Done. So we now type check and validate variable access. Isn't that beautiful? Beautiful. Type check variable access. Just like this. Oh. So we now, we can do math with variables. Ooh, that's Pog. This is Pog. This is pretty dope, boys. This is pretty dope. Maconate, give me that smile and that thumbs up once more. Thank you, Maconate. You're so positive. I love your presence around here. I love you, Eternal Wild Fox. You're all so great. Cyber Patty, epic. I'm sad you had to go to sleep. This is awesome. Let's commit to some gitte so we can share this code with the world, right? Man, I've got a dirty working tree. Oh boy. Let's figure out what to do here. So, excuse me. We have our whole next child context business. We have our function call code generation. Yeah, we don't do in reverse order yet. I guess it doesn't matter if we do in reverse order, as long as we calculate it in both places the same. So in CodeGen, to do in reverse order, or just calculate same when accessing. I think that's fine. Yeah, that's absolutely fine. Okay, so we can do that there. And then we'd like to say, what is this? We comment out some print, and then we add in next child context to our CodeGen expression calls. So we can stage that. We can do our function call and our little expression, our next child context. We're gonna need these. Alrighty. We can definitely fix the size t using ZU instead of D format for printf. We're gonna need this locals offset for sure. Symbol to address now does local variable access as well as global variable access. So that's very beautiful. We need that. CodeGen of variable accesses. Yeah, we still can't access parent scope variables unless they're global. But that will change. We just need to, for example, since we save RBP here, and then keep track of our offsets from each one, we then just need to save, when we have a nested function, the RBP offset to that function, if that makes sense. And then we can just, from the child function, use that offset to calculate the next variable offset so that our RBP offset can be added. Does that kind of make sense? So if we had another function like bar and it was just inserted right here, then you would understand that the base pointer would be updated to a new place on the stack. But to access a variable from foo, we have to use this base pointer addressing. So we would have to figure out the base pointer offset between the bar nested function and the this base pointer and this base pointer, because then we could just add that number to the number of argument it is, or the offset within here, and we can calculate the proper offset at any nested scope level. Hopefully that made any amount of sense. But that's what this is, this whole to-do commented out thing here is. Maconate says, I see you have 55 followers, not bad. That's right, I have 55 followers. I'm officially like a part of Twitch. Hey, and Neg Vorsa, speaking of followers, Negvorsa just followed. Thank you so much for the follow. We got those lurkers following in today's stream. It's pretty dope. Feel free to say hi or ask any questions if you'd like anything clarified. I'm just gonna stage it. We're going to, what changed here? Yeah, we just passed Codegen context and next child context. Those all look fine. We remove the stack pointer because we now calculate it. Yeah, we calculate our entire locals offset and add it back so that we can add the proper amount. But thank you, Maconate. It is not bad at all. I am very grateful for all 55 of you wonderful followers. It's nice. It's nice. I'm just happy that each time I go live, there are people that keep me company and keep each other happy. We all have this little happy place, our little environment we can go to that lets us escape from our horrible life and actually be okay for a few hours, right? That's at least why I'm here. I don't know about you. Alrighty. We're probably gonna have like a whole Codegen stack. Oh, it's gonna be rough. It's gonna be rough. It's fine. It's fine. Everything's fine. Yes. So then, yep, just next child context and deallocate register. Okie dokie. Codegen.h, what changed? Oh yeah, we got local offset in the context. We can print environments. That's kind of not useful, but somewhat related. We changed our delimiters for lexing. Definitely have to keep that. So we did a lot to the parsing and lexing. We're gonna do it all, because that definitely all is doing rather well. We have that issue with the parser, not parsing the last variable access, but it's fine. It is fine. Okay, and then this is just more type checking. You know what? We're gonna put it all in one commit. We could split it up, but I don't really want to. It's not like it matters, but again, it's not like it matters, so why not? We're just gonna say progress made on what's today? On stream on the 18th of August 2022. We have everything from parser upgrades to type checking variable to codegenning local variable access. Lots of progress in this commit. Known bug is that last variable access in file in program / expression body is not actually found. Yeah, why not? Is not actually found properly. Why not? Alrighty. You always snitch on yourself in the git commits. You always say like, oh, but there's a bug here, and alright, we commit to committed, now we pushy. And we are now, hello, it would pushy. There we go. We are now live. The code is all updated. Feel free to go to the GitHub down below and check this out. We now have function calls with functioning expression bodies and return values from functions and reassignments of variables, and we can have parameters named the same thing as global variables and it doesn't break things. Oh, we are doing so good. We're doing good. Can we do this? If we can do that, I'd be impressed. That's what is called emergent behavior. 174. We cannot do that. How do we get 174? We should get 79. So I bet you we're using the memory address of A. Yeah, well, maybe. Yeah, this probably gets us the memory address in racks, and then we need to dereference it like this. But it's fine. I learned yesterday that C function not really have call by reference. In the end, it's all call by value. Yeah, references are not a thing in languages. Reference is just a pointer with extra type checking, in case you didn't know. That's about it. And different, like, the type checking gives different semantics to assignment and use, right? It's basically just a pointer with a different syntax that can never be null. That's all. So it makes sense that they're passed by value. So we can't quite do this because we don't dereference the memory address properly yet. Or maybe, maybe. Let's try this. Maybe I just mistook what I shook. I did just mistake what I shaked. So I was looking at this and going, oh, A is 69, but A is reassigned to 420, and 420 plus 10 is 430, and then that was equal minus 255 to our little result that we were getting, because you can only have 1 byte return codes. So setting A, and then calling it, and then using it as, ooh, this is cool. This is so cool. This is emergent behavior, because I didn't actually write this code, it just works now. So we can compile this program into this assembly, in which A has 69 written into it, then its address is used in racks, and called to foo 69 in A, this global variable, then has 10 added to it, and that's returned, and then that return value is already in racks, so we don't need to move it, and then we return that from our entire function. That is so incredible. We're doing variable accesses of like arguments, like, this is complicated. I didn't think this would work already. This is amazing. I'm so glad we made so much progress today. So much progress today. Oh, so cool. If this blows your mind, please hit that follow button. If you have that extra $1 or two, be sure to check out that donation button. I would greatly appreciate any and all donations. Oh shit, this is worth it. Look at what Mr. Mugame is doing on the Discord. Hey, ALU and clockworking. That's incredible. That's truly incredible. Pen Eater would be jealous of your wiring. This is nice. He has some power jumpers here. So this looks to be the clock, and this must be the ALU with all the chips. Yeah, and the lights. This is very cool. Your table is so clean. You look like you're at an IKEA. I'm not trying to roast you. I'm just mentioning that's so clean. My table is never this clean when I'm working on electronics. I have shit everywhere. In any case, be sure to check out the Discord down below. Hey, I just closed my OBS. Be sure to check out the Discord down below. I make assignments. I make announcements every time I go live. I'm looking at the assignment operator. I make announcements every time I go live, so you will never miss a single stream. We say hi to everybody that shows up, so I greatly recommend it. We all have fun, we share our progress, and get to see cool things, like Mr. Mugame working on his 8-bit computer on a breadboard. Sweetness. Very sweetness. But yeah, join the Discord. Check out all the links down below in the About section. I believe we are coming up to an end on today's stream, because I don't have anything else to work on. I have plenty to work on. I just don't know, I don't have a guided Like, what will I work on next? So the coding would kind of just be me meandering around, going, what do I do here? What do I do here? I mean, we could try and go fix that parser error where we're not catching functions after... We're not catching functions after a function definition. No, we're just not catching the last variable access. That's right, that's what it was. I don't think I need all this, but it's fine. So the idea would be variable access. Should these not be lower? Yeah, it's here. So working result is node type variable access. This looks fine and all. And then we free variable. Yep, because yeah. Michael Nate says, I'm now on your Discord. Hey, welcome. How's it going? Good to see you, Blue Dragon 84 or Michael Nate. What's up? Yeah, feel free to check out the history, what people are talking about. Share your own progress. Do whatever you want. Set up little meetings. If you want to like make coding challenges with people in the Discord, do whatever you want. Just be nice is the only rule, and the ban hammer will be swift and actionable. So try not to be banned. Just be nice to people and you won't be banned. That's all you got to worry about, right? I should really link to like a whole code of conduct for the Discord so that I don't have to explain like what the rules are in the Discord myself, because there's plenty of code of conducts that we could use. And effectively, we say unknown symbol. So why are we not able to catch this last variable access? So if I said A, you can see that we just have the function call with the variable access A in it, but then we don't have anything next, which is kind of not good. So does it matter what type of expression comes before it? It does not. We just miss out on the variable access entirely. Interesting. So missing out on the last variable access. Do we miss out on the last function call, for example? Exited abnormally with code 5. Okay. So there's an issue there. So what if we have like A plus A? I mean, that should work, but it doesn't. So that's interesting. Our type checking is not perfect. Oh, but it's the same thing. We have a none on the right-hand side. What? Why? How? How work? Why? So why isn't this last one being caught? What could we have that's being done? So we try and parse variable access. And in getting to here, what else have we checked? We've checked that we don't have a parenthesis. We've checked that we don't have a colon. And we've checked that we don't have a defun. We've also checked that we don't have a lambda. So we have no lambda, we have no defun. Also, there doesn't need to be an... Oh, there does because it's continuous and like that. Okay. And then in here, see, we don't need an else here. So where does this go? To free variable. And the reason we don't need an else here, whoops, is because we continue, no matter what, from this control flow. We never break out of this control flow, we just continue and jump back up to the top of the loop. So we don't actually have to worry about anything going on. I think I can get rid of all this. It's not really helpful. With call operator, and then start parsing function argument expressions. That's exactly what we do here. Perfect. But yeah, so this will only ever happen there. And we'll jump back up to the top of the loop. Otherwise, it's a variable access. But we're still not catching it. Still get none on the right-hand side. So when we go to parse the right-hand side, what is happening of a binary operator? We do that. Thank you very much. That's a good question. Effectively, so we'll lex advance by continuing, which means that if we lexed previously and then failed, it wouldn't work. That's why we use expect everywhere. So where could it have failed that we are not working on? So we need to ensure that the function return type is a real type. Is a valid type, is what I should say. It's real, but is it valid? Okie doke. So it probably has to do with like some expected done nonsense, right? In any case, parse infix, parse binary. Okay. So here, we parse this operator if it's a thing, otherwise we leave everything alone. And in leaving everything alone, yes, we end up where? Here. And then all we do is either expect or continue. We never truthfully do any bad boy behavior. I still don't get why this isn't caught up here, but it's whatever. It's fine. In any case, so we are not parsing this last one. We may need a debugger and a breakpoint here, because I'm not seeing the error. And the error comes in when continuing. Then we lex. Oh boy. So we lex, and then say lexed blah blah blah. So let's see if we lex a at the end, right? We lexed a 3 times in a row. That tracks. So we found a after foo. So we found foo, we found a, and then we found a. So we do lex a, this last a. It's just not here. So we lex it, but the working result is not set. Why? Right? Why is the working result not set? So here would be like we parsed an integer, but we should say symbol. Symbol, value, symbol. Right? We get a bunch of symbols. A. So we get it as a symbol. The last A, the third one in the last section. It's not a lambda. It's not a defun. It's not followed by any of these. So we should be here, right? And we do. We get here 3 times. Because there's 3 variable accesses in a row right at the end. A. But something doesn't happen in between here. We get here still. So you still get 3 heres. So it's like the binary, it's like the working result is incorrect, right? because we get 3 here's right at the end. That's AAA. That's all we need. 3 variable accesses. That one isn't caught, but that causes the other one to be caught. What? What? So we have an off by 1 error in our entire parser somehow. So in getting a binary operator, we set our result or our working result effectively. Okay, so then working result is equal to a newly allocated node, which is a child of the result pointer on the right-hand side. This seems logical. So the working result is equal to the right-hand side, which works because we can do it given we give it another A to choke on, right? So we can parse into the right-hand side and then return infix operator. So we find it and then we continue and we lex advance. That seems to work. We're going to print the current token. We got plus twice. Let's put a new line in there so that this is a little more understandable. So we get plus 2 separate times. Because plus is found twice in the program. That's right. So in our simple program we have a plus 10 and then a plus a. So we get there twice, and our current token does not extend past our operator, so upon continuing, we will lex the next thing that we need. So we don't need any of that. But apparently, when we lex advance and lex this last A, we then return without writing into working result somehow? I don't even know how that works. Working result should be, what is it? So infix operator. So we pass working result as an address. I honestly have no clue. Hopefully some of you here will know and make a pull request later today or tonight or whatever. Because this is going to take me a while to find just by hand. Or we'll use a debugger. Maybe in tomorrow's stream. In any case, we weren't able to fix it. But we were able to properly compile and return values from function calls. So we can have foo of a here, go to code.s, which is our generated assembly. So here's the assembly from this program. Gets converted to this assembly. And then this assembly we can build with as, like these, into an object file. We can then build, or link that object file into an executable. And then we can run the executable. And you see that shell command failed with code 79. Isn't that beautiful? I think it's beautiful. We did it. Cool, you can see the file update. Ooh. It's fun. But yeah, shell command failed with code 79 and no output. How beautiful. So we are taking A, which is 69. We add 10 to it, which is returned as an integer from foo. and then foo, returning 79. This is our last expression, so our entire program will return that. This is very cool. This is very cool. I like this. In any case, that will be the stream for today. Be sure to check out the Discord like Maconate did and joined us just now. So nice of him. We get announcements every time I go live. I can't speak today. We get announcements every time we go live. We have a general chat where we can all share our progress and do everything and be nice to each other. It's so much fun. There's the YouTube down below if you'd like to see any of my previous broadcasts. And then there's the donate button. If you would be so kind and so generous, I will read your message and if you leave your username on stream, as long as it's appropriate. In that case, I think I have done my entire ad read effectively, right? I am entirely out of things to say. So I would like to take this time to thank you for watching. Hey, first time chat from a viewer, Neg Vorsa, who followed earlier. He says thanks. Thank you, Neg Vorsa, for being here. Thank you, Maconate, Eternal Wild Fox, Cyber Patty, Alderson28. Who else did we have? We had Chaser Mercury in here. We had VMe was in here earlier. It was pretty dope. He was great. And I really appreciate all of you for watching, all of you for tuning in. We will be continuing work on this compiler, on this language, so be sure to stay tuned and follow everywhere you would like. I will see you in the next stream. Bye! Have fun. Bye-bye. Bye, Mom. Bye, Dad. Bye, family.